Alright, this is question 3. It tells us to look at this function f of x equals x minus 3 times x plus 4. And what we're trying to do is first off determine the x-intercepts of this graph. Now if you watch the first two questions of this outcome 4, then you saw that all we need to do to figure out the x-intercepts is to set the equation equal to 0. So we're going to say 0 is equal to x minus 3 times x plus 4. And the way that this whole right side would end up equaling 0 is if either this part or both were equal to 0. Okay, because if this was 0, then it's 0 times whatever x plus 4 is here. If this was 0, it's 0 times x minus 3, but again, 0 times anything is always 0. So we just figure out what we could plug in here to make this set equal 0, and that's going to be positive 3, since 3 minus 3 is 0, and what we would plug in here, which would be negative 4. Because negative 4 plus 4 is 0. So those are the two x values that will give us an output or a y value of 0. And so those are the x-intercepts of the graph. So we have 3, 0, and 4, 0 as our x-intercepts. Now, the second part of this question, I'll erase this a little bit. The second part of the question says, what if, let me rewrite those x-intercepts down here in the corner. So these are our original x-intercepts. It says, what if there was a plus 2 on the end? What would happen to the x-intercepts of the graph? So think about this. Anytime we are adding a number to the end of an expression, all we're doing is we're taking whatever y value this would give us, and we're adding 2 to those numbers. So for instance, if I plug in 3, this would be 3 minus 3 times 3 plus 4. Right? 3 minus 3 gives us 0. 3 plus 4 gives us 7. So the reason that this was one of the x-intercepts and had an output of 0 is because 0 times 7 was 0. But now we're putting this plus 2 on it. So now, when I do 0 times 7, I still get 0, but I'm going back and adding 2 to that value. So by plugging in 3, my output, when I use an input of 3 or an x value of 3, is actually going to end up being 2 now. So that means no longer will 3 be an x-intercept. Okay, same thing for negative 4. If I plug that in, this is going to become 0, and 0 times whatever negative 4 minus 3 is here. It's still going to be 0, but we're adding 2. So in both cases, now we're going to get a y value of 2 instead of 0. So that means our x-intercepts of this graph are going to change. They can't be the same. So our previous x-intercepts were shifted up from the y value of 0 to a y value of 2. And in order to figure out what the new x-intercepts are, we're going to do a couple things. First off, I want to simplify this expression. Okay? So I want to multiply through, use the distributive property, x times x is x squared plus 4x, and then the same thing with this term. Negative 3 times x is negative 3x, negative 3 times 4 is negative 12, and then we still have that plus 2. Right? So this is our function now. So x squared plus 4x minus 3x minus 12 plus 2. Let's simplify this a little bit. We'll just have our x squared term. 4x minus 3x gives us plus 1x. And then we have a negative 12 plus 2, which just simplifies to negative 10. So I can first see if I can factor this expression. I'm looking for factors of negative 10 that add up to positive 1. Okay? So factors of 10 are 1 and 10, 2 and 5. Now since I want to multiply the two numbers and get a negative, that means one needs to be negative and one needs to be positive. And the way I determine which of the two numbers is going to be negative or positive is the bigger number will always have the symbol or the sign of the middle term. So since the middle term in our expression is positive, that means the bigger numbers need to be positive and the smaller ones need to be negative. But we're going to still run into a problem here because negative 1 plus 10 is 9, negative 2 plus 5 is 3, and I wanted 1 when I combine those. So that means this is not, we can't factor this expression to figure out where the x-intercepts are. It doesn't mean that there's no answer here, it just means we can't factor it into whole number values, at least at this point. So, as when we look into our bag of tricks, our sort of tool back here for how we can solve this problem, the next step we go to is the quadratic formula, which again is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So, I'm going to just simply fill this out. Negative b is negative 1 over 2a. There isn't a number here, but we know that's a hidden 1, so 2 times a would just be 2 times 1, which is 2, plus or minus the square root of b squared, so 1 squared, minus 4 times a, which we said was 1, times c, which is negative 10. Again, all that will be over 2a, which we already saw was 2. Okay, so we have negative 1/2. I'm just going to scoot this over a little bit. Negative 1/2 plus or minus the square root. 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 10 is positive 40. We have a negative times a negative, so this becomes positive or plus 40. Okay, and all that is over 2. We have negative 1/2 plus or minus the square root of 1 plus 40, which is 41, all over 2. Now, the square root of 41 is not going to be a whole number value, so I'm going to reach over and grab a calculator. And when we do the square root of 41, we get 6.4 approximately, and then divide that by 2 and we get 3.2. So our answer becomes negative 0.5 plus or minus 3.2. And so that means we're going to take negative 0.5 and we're going to add 3.2 to that value, and we're going to turn around and subtract it. So if I add negative 0.5 plus 3.2, that gives me 2.7. And if I do negative 0.5, I'm kind of running out of room on my board here, but negative 0.5 minus 3.2, we get negative 3.7. Okay, 3.7. And I know that's written very small, but I'll write it a little bit bigger over here now. So our new x-intercepts are going to be at 2.70 and negative 3.70. Okay, so they previously were at 30 and negative 40. Now we're at 2.7 and negative 3.7. Okay, so those would be the new x-intercepts. We couldn't get it by factoring like we did the first term, which was already factored for us, thankfully. But we couldn't just figure out what to plug in the two values because we couldn't factor it, so we go to the quadratic formula, and then it's just a matter of simplifying. Okay, it always looks a little more messy than it actually is. Right? Once you get it here, it's just a matter of simplifying your term one step at a time. So there's the second part of the expression. Now I'm going to erase this one more time. And if for some reason you needed to catch up or go back and get some of those numbers or see something else, remember you can always just scroll back along the video and see what you've missed, or pause it to kind of catch up or think about something for a minute. So I want to do the last part now. Clear this up. The last part says what would happen if there was a 2 in front of this. Okay? So let's think about what would happen. If I plug in those original x-intercepts, which were 30 and negative 40, if I plug 3 in for x, I'm going to get 3 minus 3 times 3 plus 4. Okay? So this is still going to be 0 in the first parentheses times 7. And 0 times 7 is 0, but then I'm taking that answer, 0 times 7, and multiplying it times 2. So I still have 0 times a number. This is still going to end up being 0. Okay? If I plug in negative 4, once again, I will also get 0. Okay? Because now instead of adding something on, we're just multiplying our answer by 0 still. So anytime you multiply anything by 0, it remains 0. So this actually tells me that these x-intercepts are going to be the same this time. Between this function and this function, you get the exact same x-intercepts, because all you're doing is taking the y values and doubling them. That's what this 2 in front does. Instead of adding 2 and moving them up, we're basically stretching them in the y direction. Okay, so if you looked at any point on your graph, and say we had a point here, if we had a point that was some distance below the x-axis, now it's going to be twice that distance. So it would now be down here. There was a point a little bit above the x-axis, maybe somewhere in here. Now it's going to be twice as far from the x-axis. So the y values, the distance from the x-axis, those are doubling. Right? It's getting farther away. However, the values that will not change are these two. Anything that has a y value of 0, if you double 0, it just stays 0. Okay? So in this case, those points are going to be the ones that just stay where they are. They're not moving. Same x-intercepts. And this is actually very useful because if you have an expression, something like this, let's say we had 2x squared plus 2x minus 24. Okay. this tells me that if there is something that I could factor out of this expression, in this case a 2, I can factor a 2 out of each term. Divide this by 2 and I'm just left with x squared plus x minus 12. Then I can factor this and basically ignore the 2 and I'll still be able to find the x-intercepts that way. Okay? And this one is actually what would factor into the problem that we're looking at. This expression x squared plus x minus 12 is factorable into x minus 3 times x plus 4. Okay? So whether it looks like this or this, you're going to get the same x-intercepts, because once you factor out the term that you can divide each one by, in this case the 2, you get the same 2 x minus 3 times x plus 4 terms. So same x-intercepts if there's a number in front, different x-intercepts if you're adding a number or subtracting a number at the end. Okay? So hopefully that makes some sense. Again, just keep watching the other videos to try and tie in all these concepts about the quadratic functions and how we can find the key features, x-intercepts, things like that.